Hey guys, it's me again, Clang, and welcome to another episode of Miss Bellion's Classroom. Today we are going to discuss about potential and kinetic energy. But before that, I have a question for you. If an object is not moving, does it have energy or not? If you would like to learn about it, please continue watching and try to be interactive. The first activity that we're going to do today is Edpuzzle. In Edpuzzle, I'm going to play a video, and in between the video, there are questions that will pop out. It could be multiple choice question or open-ended question. Of course, the questions that will pop out is related to the video. So meaning you need to focus and watch, understand, comprehend the video. All right? Are you ready? Okay. By the way, in this activity, you might be needing your calculator with you. If you don't have scientific calculator with you, you can use your cell phone. So are you ready? Again, in between this video, there are questions that you are going to answer. Try to be interactive as you can. I will start now.
Hi, it's Mr. Anderson, and today I'm going to talk about potential and kinetic energy. Remember from the last podcast that energy is the ability to do work, and work is a force times the distance. So we measure work and energy both in joules. Now,
okay, our first question is, energy is the ability to do, power, work, force. Again, energy is the ability to do, power, work, force. Did you say work? Let us try. Very good. It is work. Let us continue.
Now, there's a law of the conservation of energy. In other words, that law states that energy can neither be created nor destroyed. Now, it can be converted into mass according to E equals mc squared, but we'll get to that later. And so, since energy can neither be created nor destroyed, it can be converted. And so the two terms that we generally talk about when we talk about storing or using energy are potential and kinetic energy. Now, I'm talking about potential gravitational energy and kinetic energy. And so we also have potential energy, for example, in the chemical bonds of a molecule, but I'm not talking about that. And so the two types of energy that we have are potential energy, and that's energy due to position, and kinetic energy, and that's energy due to motion. And we have equations for each of these.
All right, this is our next question. Kinetic energy is the energy of chemical bonds, position, or motion. Again, kinetic energy is the energy of chemical bonds, position, motion. Did you say motion? Let us try. Next question. Potential energy, or PE, is the energy of position, motion, or atoms. Again, potential energy, or PE, is the energy of position, motion, or atoms. Did you say position? Let us try. I will click submit. On the first question, you got it right. Kinetic energy is the energy of motion. How about the second question? Again, you got it right. Potential energy, or PE, is the energy of position. Very good. Let us continue.
These potential energy is mgh, where m is mass, g is gravitational acceleration, and h is the height. And then kinetic energy is 1/2 mv squared, where m is mass and v is the velocity of the object. Now, the best place to look at how energy is converted.
Okay, for our next question, to calculate gravitational potential energy you need, look at the formula for potential energy. You need to check all that is needed. Again, to calculate gravitational potential energy, you need to look at the formula for potential energy. You are going to check all what is needed. The, the choices are mass, height, gravity, velocity. Again, mass, height, gravity, velocity. Did you say mass? Okay, let me check mass. Did you say height? Let me check height. To calculate gravitational potential energy, you need, this is your hint, look at the formula for potential energy. You are going to check all that is needed. These are the choices: mass, height, gravity, velocity. Let me repeat the question. To calculate gravitational potential energy, you need mass, height, gravity, velocity. Again, the hint is look at the formula of potential energy. You are going to check all needed. Did you say mass? Okay, let me check mass. Did you say height? Let me check height. Did you say gravity? Let me check gravity. Next question. The formula for kinetic energy, or KE, is equals to mgh 1/2 mv squared, or mv squared. Again, let me repeat the question. The formula for kinetic energy, or KE, is equals to mgh 1/2 mv squared, or mv squared. Did you say 1/2 mv squared? Let me check that for you. And then let us submit. For the first question, you got it right. The formula for potential energy is mgh. That is why we need the mass, height, and gravity. Very good. For the next question, the formula for kinetic energy, or Ke, is, you got it again right, 1/2 mv squared. So let us continue the video.
Energy is converted from potential to kinetic energy is in a pendulum. A pendulum is simply a weight attached to a string. And so if I hold a pendulum at one side and don't let it go, it has a certain amount of potential energy. When I let it go, the pendulum will swing back and forth. That energy is converted from potential to kinetic, and then back to potential energy, and then to kinetic, and then potential, over and over and over again. And so when that ball is sitting at the top, it has all potential energy. When it's at the bottom, it's converted all of that energy into energy of motion. And so when it's halfway down, we would say that it has a combination of potential and kinetic energy. And it's just converted. Now, will a pendulum swing forever? No, because we're going to lose a little bit of that energy in friction, in heat, in sound as it moves. And so eventually that pendulum's going to come to a stop.
All right, this is our next question. Why does pendulum come to a stop? First, it will lose some energy to friction, heat, and sound. Second, gravity is pulling it down. Third, it gets tired. Again, let me repeat the question. Why does pendulum come to a stop? It will lose some energy to friction, heat, and sound. Gravity is pulling it down. It gets tired. Did you say that the correct answer is it will lose some energy to friction, heat, and sound? Let me check that for you. Next question. When a pendulum is at its highest point, it has all PE or KE. Again, when a pendulum is at its highest point, it has all PE or KE. Did you say PE? Let me check that for you. Next question. When a pendulum is at its lowest point, it has all KE or PE. Again, let me repeat the question. When a pendulum is at its lowest point, it has all KE or PE. Did you say KE? Let me check that for you. Let us submit. For the first question, you got it right. Why does a pendulum come to a stop? It will lose some energy to friction, heat, and sound. Very good. Let us see if you got the second question right. Very good. You got it all right. When a pendulum is at its highest point, it has all the PE or the potential energy. Good job. How about the third question? When a pendulum is at its lowest point, it has all the Ke or kinetic energy. Very good. Let us continue the video.
And so let's do a couple of problems with potential energy and kinetic energy. Potential energy, remember, is measured as mgh, where m is mass, g is gravitational acceleration, and h is height. And so let's say, for example, that I climb to the top of a 10-story building. And so first of all, we have to know my mass, which is 78 kilograms. We have to know the acceleration due to gravity, or g, which is negative 9.81 meters per second squared. And then we have to convert that 10-story building into meters. And so a 10-story building is roughly 32 meters high, or that's our h value. And so if we simply multiply those all together, we get 24,485.76 joules. And if we do significant digits, that's 2.4 times 10 to the fourth joules of energy that my body has at the top of a building. And as long as I stay at that top of that building, I can use that on the way down. I don't want to jump off the top because I don't think I'd be able to make it. The next type of energy is called kinetic.
If a 10-kilogram ball is sitting on a 5-meter high ledge, what is its potential energy? You will be needing your calculator here. Again, we are asked for the potential energy. The formula for potential energy is mgh. So in the problem, what is our mass? You were right, 10 kilogram or 10 kilograms. In the problem, what is our gravity? Very good, 9.81 meter per second squared. In the problem, what is our height? Very good, it is 5 meters. So therefore, what is the correct answer? What is the potential energy if a 10-kilogram ball is sitting on a 5-meter high ledge? What is its potential energy given that our gravity, or that is the gravity, is 9.81 meter per second square? Is it 480 joules, 490.5 joules, 500 joules, or 500.5 joules? Did you say 490.5 joules? Let us see if you got it right. Very good. So again, our mass is 10 kilograms. Our gravity is 9.81 meter per second squared, and our height is 5 meters. Given the equation, potential energy is equals to mgh. Multiplying all that is given, our answer is 490.5 joules. Good job.
Called kinetic energy. energy of kinetics or motion is 1/2 mv squared. And so that's energy due to motion. And if I jumped off a 10-story building, I would convert all of that into kinetic energy at the bottom of my fall. But I don't want to do that. And so let's do one dealing with a baseball. Let's say I pitch a baseball, and there are two different pitches. When I throw a baseball, probably throw it around 20 miles an hour if I were to throw it. I'm not a very good thrower, but a really good major league pitcher will throw it at 100 miles an hour. And so let's figure out how much kinetic energy would be in one of my throws and then those of a pitcher in the major leagues. First of all, we have to figure out the mass of the baseball. Mass of a baseball is 0.145 kilograms. And since we're doing kinetic energy, the only other value that we need is the speed. That's roughly 9.0 meters per second. Remember, on all these, we always have to convert it to meters or meters per second, if it's a velocity. A 100-mile-an-hour pitch, then, is roughly 45 meters per second. And so first of all, let's figure out how much kinetic energy my pitch would have, a 20-mile-an-hour pitch. We use the equation 1/2 mv squared, where m is 0.145 kilograms and v is 9.0 meters per second. We then take that times 1/2 and square the velocity, and I get, using significant digits, 5.9 joules of energy. Now let's try the faster pitch. It's 100 miles an hour, so that is 45 meters per second. So we're going to use 1/2 mv squared. Our mass remains the same, or it's 0.145 kilograms, except our velocity now is 45 meters per second. If I multiply that across using significant digits, I get 150 joules of energy. Again,
For our next question, what would happen if you change the mass of the ball? Example, throw a golf ball instead. How would the change in mass that affect the kinetic energy? Would be less kinetic energy? Would be more kinetic energy? Or stay the same? Again, what would happen if you change the mass of the ball? Example, throw a golf ball instead. How would the change in mass that affect the kinetic energy? Would be less kinetic energy? Would be more kinetic energy? Or stay the same? Did you say would be less kinetic energy? Let us try. Very good. There would be less kinetic energy.
Again, when I pitched at 20 miles an hour, it was only 5.9 joules. And so even though that pitcher is throwing it 5 times as fast, he's getting roughly 25 times the amount of energy out of that pitch. And that's why, if you look at the equation, the velocity being squared is super important to understand that. And so you can solve
For our next question, what is the kinetic energy of a 5-kilogram bowling ball rolling at a velocity of 10 meters per second? 25 joules, 50 joules, 250 joules, 500 joules. Again, what is the kinetic energy of 5-kilogram bowling ball rolling at the velocity of 10 meters per second? So what is the formula of kinetic energy? It is 1/2 mv squared. In the problem, what is our given, or what are our given? Do we have the mass? Yes, the mass is 5 kilogram. Very good. Do we have the velocity? Yes, the velocity is 10 meters per second. So now we are going to use the formula 1/2 mv squared. So what are we going to do is, since we have square root, we are going to get the value of our velocity. So 10 square root of 10, okay, times 5, okay, divided by 2, since it is 1/2 mv squared. So the answer is, did you say 250 joules? Let us try. Very good. It is 250 joules. Let us continue.
Complex problems now that you know the equation for potential energy and kinetic energy. For example, in class, we figured out based on the speed of a sprinter and the mass of a sprinter, you should be able to figure out how high they could pole vault if all of that kinetic energy were converted into potential energy at the height of that vault. But that's it. That's in summary again, the ways that we can measure energy in joules, and it's the ability to do work. And remember, it's always converted from potential or energy due to position to energy of motion or kinetic energy.
For our last two questions, in which tree position of this roller coaster ride is the potential energy the highest? Is it the C, E, F, A, B, D, B, D, F, or A, C, E? Let me repeat the question. In which tree position of this roller coaster ride is the potential energy the highest? Is it the CEF, ABD, BDF, or ACE? Did you say ACE? Let us try. Next question. What are three positions are the kinetic energy the highest? Is it BDF, ACE, CEF, BCD? Again, let me repeat the question. What three positions are the kinetic energy the highest? Is it BDF, ACE, CEF, or BCD? Did you say BDEF? Let me try. Let us submit. For the first question, you got it right. In this position or in this roller coaster, the one that is in highest position has the highest potential energy. That is why the answer is ACE. Very good. For the next question, you got it again right. So if the position is in the lowest, that means there is the highest or have highest kinetic energy. That is why the correct answer is BDF. Good job, guys. There you have it, guys. That is our first activity with potential and kinetic energy using Edpuzzle. So I hope you learned something. But before I end this video, I would like to ask you the question from the beginning of this video. If an object is not moving, does it have energy? Very good. Yes, it has energy, and it is called potential energy, which is the energy in position. Good job. So now, click the next video for our next activity.